solve this equations. X square minus y square equals to 24, xy equals to 35, and what is x plus y equals to. So let this be equation 1 and this be equation 2. So the first thing what we are going to do is, let me take the equation 1. So I have from equation 1, x square minus y square is equal to 24, and this I can expand it to a plus b times a minus b. So that's x plus y times x minus y is equal to 24. Now I'm going to square both sides. So what do I have when I square both sides? So x plus y times x minus y, the whole squared, is equal to 24 squared. I'll just put it x plus y the whole square times x minus y the whole square is equal to 24 squared. So now I'm going to expand. This is a plus b the whole square and this is a minus b the whole squared. So I'm going to get x square plus 2xy plus y square. And then here I'm going to get x square minus 2xy plus y square is equal to 24 squared. Then what do I have? Xy from equation 2, which I've marked at the beginning. From equation 2, xy is equal to 35. This is what I have. So I'm going to substitute this. So I have x square plus 2 times 35 plus y square, and here I have x square minus 2 times 35 plus y square is equal to 24 squared. What do I have? X square. Let me arrange it as well. X square plus y square plus 2 times 35 is 70. And then I have x square plus y square minus 70 is equal to 24 square. Now as you can see, let me take this as a and this as b and this as a and this as b. So if I have a plus b times a minus b, I can use the formula a square minus b square. So what do I have here is x square plus y square, that is my a. So I'm going to square that, a square minus b square, b is 70, so I have 70 square, which is equal to 24 the whole square. Let me send this here. So I have x square plus y square the whole squared is equal to 24 squared plus 70 squared. And what is 24 square plus 70 square? That is for just 576 plus 70 square is 4900. And then when we add up, we get 5476. So I've got x square plus y square the whole square is equal to 5476. Now I'm going to take square root on both sides to eliminate the square from here. So I have x square plus y square is equal to square root of 5476 is plus or minus 74. Now as I already know that xy is equal to 35, let me take down this formula. X plus y, we need to find out x plus y. So x plus y the whole square would be, that is a plus b the whole square. So x square plus 2xy plus y square. And then I'm going to substitute this. So what is my x square plus y square? I can even arrange it like this. X square plus y square plus 2xy. So what I can do is x square plus y square is plus or minus 74 and plus 2xy plus 2 times xy is 35. So I'm going to put it here. So I have plus or minus 74 plus 70, x plus y the whole squared. That is x plus y the whole squared. I'm going to have two solutions, which is the first one. What I have is x plus y the whole square is equal to plus 74 plus 70, and the other one is x plus y the whole square is equal to minus 74 plus 70. Now let's solve for this. So plus 74 plus 70 is 144. Here I have x plus y the whole squared. So taking square root on both sides, cancel this. X plus y is equal to under root of 144 is plus or minus 12. So I've got one value of x plus y here. And then let me find out this one. So x plus y the whole square is equal to negative 4. So if I take square root on both sides, this and this gets cancelled. So I have x plus y is equal to, as we know that I square is equal to negative 1. So I'm going to put that in under root of 4i squared. So x plus y is equal to square root of 4 is 2 I squared. So square and root gets cancelled. So I'm left with 2i, that is plus or minus 2i. And that's our four solutions. Plus 12 minus 12 and plus 2i